Recording in progress. This meeting is being recorded.
Hi, everybody. Happy Monday.
Happy Monday.
Yep.
Best thing about Monday is tomorrow's not Monday.
It is definitely that kind of week for me. I'm very excited for it to be not Monday anymore, but I am excited to be in class with y'all tonight.
Me too. That's the way I feel. It'll give me something to look forward to.
Okay, I am going to dive right in with announcements as it is 6:02, and then I will pass things over to fantastic Dr. Vicky as usual. Welcome everybody. Good to see you all again. Thanks for hanging in there when I was only available via Slack last class. I am, of course, here today. Quick recap of announcements, and as always, these can be found in our announcements channel. Thank you all for doing the learner check-in survey. This week, I'm going to be working on analyzing the data. I'm going to go over it with your TAs on Thursday, and then sometime next week, I'm going to share the results with you, and we'll talk about what changes we are going to be implementing as a result of that survey. So again, your feedback is absolutely very much appreciated. So thank you for that. Graded assignment 2 is now past due, so please submit this ASAP if you have not already. And as a reminder, for graded assignment 1 and graded assignment 2, if you scored under a 1 on either of the assignments, you do need to submit revisions. Ask your TAs if you have any questions about that or about what revisions you need to make. And speaking of graded assignments, graded assignment 3 is due Thursday, June 2nd, and this will come up faster than you think. You already have enough information to get started based on the classes that we've had so far. So please don't wait until the last minute. Definitely go ahead and start on that ASAP. And just a couple of notes about things that are coming up. Our next catch-up day is May 26th, and we will have a guest speaker again. I believe it's going to be someone from PLA, Philadelphia Legal, who will talk to you about some different programs that they have in case that would be useful to anyone in the class. But I'll post more info once I have our speakers confirmed. And also upcoming, we have no class on Memorial Day. That's May 30th. And again, I will post a reminder about that. These dates and all of our class dates can always be found on the academic calendar, which I linked in the announcement and is on the homepage of Canvas. So if you're ever not sure if we have class on a certain day, that is where you can check. And that also means that you will have a catch-up day and then kind of like an extra catch-up day before graded assignment 3 is due. So it's a little bit of extra time there. Sorry, I'm just checking chat to make sure everything sounds okay. A little bit of extra time there to work on graded assignment 3. But that is all I have for today. So thank you for listening. And I'm going to go ahead and pass it off to Dr. Vicky.
Thank you, Leah. That was great. I've been learning to go and look into Canvas, and so I know what the announcements are too. They're very thorough. I really appreciate that. Okay, guys, a couple things. We're going to move a little faster tonight because there's actually 3 lessons tonight. There's scope, there's primitive data types, and then exceptions. And they're all 3 relatively vital at this point in time before we start into the front end development in about a week. And I'm going to give you access to all of these when we're done so that you can work through them if you would like. I even put 2 of them in Replit so you can run through them if you want to later. So just try to relax, breathe, and take in what we're talking about as it relates to what we've done already, because this is just adding to it, adding a little bit more decoration, if you will, to the icing on your cake. Couple things to update you on. Const, when we were talking about CONST, when you've been around 100 years like I have, we remember when it was construct. Somebody pointed it out, and it is constant. We'll be going over that today anyway, but the const is constant. And when you're talking about scope, local and global, that can be inside a function, or as we were talking about, when you're uploading or initiating new programs or packages in your code. So there are two areas for scope, and it just happens that they're both local and global. And when we get into Visual Studio Code, you'll see what I mean. And again, const is constant, and you'll see here shortly the value of that and why that's so important. So what you're looking at right now is the lesson I put into Replit that I will make sure everybody has a link to so you can play with it later so that you can run through it. And if you look over here on the right, I actually do have the HTML file as well, because I want people to be able to see what we're running, and you'll be able to see it. So I do have all of that here for you so you can play with it. But today we're going to go over the lesson part. We're talking about scope. Again, it determines, when we're talking about it as far as JavaScript, writing scripts, it determines the accessibility. And what we mean by accessibility in code is visibility of your variables. And can they be accessed when you write your code, or are they invisible to other functions in your code? So that's what we're talking about when we say accessibility or visibility, is when you write a variable, where you put it determines whether it can be used outside of that function block or not. So JavaScript has three types of scope that we'll be talking about. We'll be talking about block scope, function scope, and global scope. And these are almost, I know we get bombarded with vocabulary terms, but these almost mean exactly what you think they would by reading them. If when they don't, I like to tell you, but block scope, function scope, and global scope. So let's look at some block scope. Before ES6, which was in 2015, JavaScript had only global scope and function scope. So we have added block scope since then. And we introduced also two new JavaScript keywords, let and const, which means constant. So we're going to talk about how these come into play even a little bit more from how we have been using them. And these two keywords provide block scope in JavaScript. Now let's take a look at what we mean by block scope. Variables declared inside a block. What do we mean by block? The curly brackets right here. If a variable is declared between the opening and closing curly bracket, that's considered to be inside the block. Variables declared before or after the curly brackets are considered outside the block. So that kind of makes sense. It actually is exactly what it sounds like it would be. So in block scope, if a variable is declared inside the block, it cannot be accessed from outside the block, which makes sense, doesn't it? It's blocked off. It's got walls around it. So if we write a variable, like right here in the example, let x equals 2, we're declaring a variable by the name of x, we're assigning it a value of 2, but it's inside the block. If you see, we have the opening and closing curly bracket. It is inside this block. So x cannot be used here, which means what? Outside the block. So when you go back and look at these notes, it cannot be used outside the block. So variables declared with the var keyword, this is interesting, cannot not have a block scope. So when you're talking about the difference between let and var, as far as declaring variables, I told you a little bit earlier that we'll get into the minutia of the differences later, and we're getting there now. You cannot use var to declare a variable if you need it to have a block scope. So just something to keep in mind. Another reason why I use let the majority of the time. And variables declared inside a block can be accessed from outside the block. Okay. So if you use var, you can't have a block scope by pure definition. So based on that particular rule, variables that you do write in here, like if you had var x equals 2, it can be used outside. So here's your example. The same thing as above. The only difference is we're using var instead of let to get our variable. So we have var, a variable of x, and we're assigning it a value of 2. Because it's a var and there is no block scope with var, you can use the variable outside of the curly brackets. So that's the biggest difference between let and var so far is it use let, it cannot be used outside of the curly brackets. Use var, it can. And the reason is using var, you can't declare a block scope, which is what this does. So that's why we're doing that. Now, JavaScript local scope, variables declared inside a Java function become local to that function. It's like a neighborhood that's surrounded by gates. And those are the curly brackets that close around a function. And all of the neighbors in there are local. Okay. So if you declare a variable inside a JavaScript function, it is considered local to that specific function. So what we're saying here is function. We're declaring a function right here. Its name is my function. We have the parentheses, and right here we have the open and close curly brackets. Okay. This is where we write the code, isn't it? So what this means is if you write a variable inside here, inside these curly brackets, and how do we know it's a variable? It says let, right? So let car name equals Volvo. That's considered local to the function. Why? Because we have function and then the curly brackets and the code inside of it. So if it starts with function and then you have the let, this variable now is local. It's part of the neighborhood defined by this particular function. What does that mean? The code cannot be used before the function and after. Okay? You cannot use the same car name right here, this variable, before the function or after the function. So when you hear the word local, I like to say if it's outside of my neighborhood, which is determined by the curly brackets of this function, we can't use the same variable name. So it can't be used before or after because it's just purely local. That's like where I live in the villages. We can drive golf carts everywhere if we stay local to the villages. If we go outside the gates, we can't. So it's just local to the function. Okay, and local variables have what we call function scope, which makes sense, doesn't it? That's what we just said. They can only be accessed from within a function. So that is a function scope as well. Since local variables are only recognized inside of their functions, variables with the same name can be used in different functions. Now, would that be confusing? Very, because if you use a variable car name here, that's a Volvo, and a couple functions down, you use car name again and put Genesis, you're using the same variable name, which you can, because this one was local, but now you're going to have 4 or 5 different variables named the same thing. It's going to get very confusing. So be careful about doing that. Local variables are created when the function starts. So when this function starts, function my function, this variable is created. That's the first thing that happens. And it's deleted when the function is complete. So when we run the function, run the loop, and whatever closing event that we put in there, when we run the closing event and the function or the loop stops, we delete the variable until we run the function again. So it's only alive, it's only valid in our program while the function is running. When the function is not running, the variable is not in existence and it's not running anywhere in the program. Now let's talk a little bit more about the function scope. Each function, every new function creates a new scope, which would make sense because the variables are local to that function, right? So every new function creates a new scope. Variables defined inside a function are not accessible from outside the function. That's what we've talked about. We create a function here, variable name, car name is Volvo, that's a function scope. So what happens is we cannot let car name running the Volvo, we cannot pull and access this from outside. We cannot do it outside of this in closing bracket or before. We can only use and car name this variable inside this function. Okay, and that's with a var. Now look at function, my function let. Everything looks similar. That's still a function scope, right? Let and var, they're both car names. They're both function scopes. They're completely housed within the opening and closing brackets, the neighborhood, the fence of your function. That's also a function scope. And a function scope also can be a const car name function scope. So you can declare a variable any one of these three ways based on your needs, and they're all three a function scope, which means what again? It can only be accessed inside the function, not outside before the function starts or after it ends. So in other words, no matter how you declare your function, if you declare a variable inside of it, it's a function scope and can only be accessed from within it. So it's a lot of words to say. If you write a variable inside of a function, that's the only place it's going to be used. Now let's look at how you declare a global. Local was inside of the neighborhood, inside of the function. Now we're going to talk about a variable that's declared outside a function. If it's inside of the closing brackets, the curly brackets, it's local, right? If it's outside, if we declare a variable before or after, it's not local to the neighborhood. Now it's global. So let's look at an example. We declare the variable right here, let car name equals Volvo. It's the same variable, but it's before the function starts, isn't it? The function starts and ends right here. So we declared the variable outside of the function. So code here can use the car name. We don't have to only use it inside the function because we declared the variable outside of the function. So it's really simple. If you declare it inside the function, it has to be used inside. If you declare it outside the function, it has to be used, it can be used outside or inside. So it depends on where you want to use them, of how you're going to place them. And again, as you can see, it's the same variable. It's just now we can use it outside of the function. And just for a little tip, a global variable has global scope. What that means is all scripts and functions on your web page can access it. So you can use this variable car name on any JavaScript function on your entire web page or web app because it was declared outside of the function and it's global, which means it's free to use in any of your functions. So variables declared globally outside any function have global scope. They can be accessed from anywhere in the program. And variables declared with var, let, and const are similar when declared outside the block. Let me say that again. They're very similar when they're declared outside of the function, either before the function or after. They're very similar. They all have global scope if they're declared outside of the function. Var x equals 2 is a global scope. X equals 2 with let is global. Const x equals 2. They're all global. Why? They're not declared inside of your function. So that's how you know. Inside the function, local, like your neighborhood. Outside of the function, global, like outside of your neighborhood. So that's pretty much where the similarities are going to end. Objects and functions, as we've learned, can be variables in and of themselves. But scope determines the accessibility of your variables, your objects, your functions from different parts of your code in your entire program. So that's what scope determines. Where can they be used? Are they restricted to just this one function? Are they restricted to just this one component, to this one page? So that's what scope is going to determine for you. Now, there are times when it's automatically going to be a global scope. If you assign a value to a variable that has not been declared, it becomes automatically global. It just defaults to that. If you assign a value to a variable and it hasn't been declared yet, it will automatically become global. So let's look at the example. This code will declare a global variable, car name. We're doing the same thing. Here's the variable, car name. Okay. Now, we're going to declare it. The value is assigned inside a function, isn't it? Right here. But it's global. Can anybody guess why by looking at this?
Because you didn't use let, var, or construct.
Fantastic. Was that Damien?
Yep.
Damon, that's exactly right. We didn't declare it because we didn't say let, var, or const. So that's exactly why it's automatically a global function now. It can be used anywhere in your program. Not necessarily a bad thing unless the way you're writing it, you don't want it to be used for that. But if you just put car name equals Volvo, you can do that. But without let, var, or const, it's going to automatically be global and can be used anywhere in your program. Now, this is the warning right here. Do not create a global variable unless you actually intend to. Because global variables or functions can overwrite window variables. And what I mean by that is you're going to have global variables or functions in your script, in your JavaScript. And you're going to have window variables in your HTML when we get to that here in a few days. So you have to be careful that if you create a global variable, it might be accessed in your windows when you didn't intend it to, because they're called the same thing. It'll be pulled in your windows when you call it and you don't intend it to. So I'm very infrequently ever use global for that reason. If I need to use it again, I'll just declare it again and start over. That way I'm not making a mistake of using the same variable or function in both global or my window variables. And you'll see what I'm talking about when we get to HTML. And any function, including a window object, can overwrite your global variables and functions. So it kind of is just like loosey-goosey. If you declare it global, anybody can use it anywhere, anytime. That's like putting something on Craigslist. it's available for anybody, and it may not be used exactly as you intend it to. So don't use global unless you really have a good reason. Now let's talk about how long does a JavaScript variable live, right? We declare it, let car name equals Volvo. We've declared it. When the function starts, it comes alive, and then it stops when the function ends. But what is the lifetime of it? How long does it live? The lifetime of a JavaScript variable starts when it's declared, let, var, const. Function, local variables are deleted when the function is completed. Now, deleted is kind of a misleading word. It's deleted from the system, the act of running code, once the function is completed, but it's still there if you pull the function again. It's just not in the act of running code. And in a web browser, Google Chrome, for example, global variables are deleted when you close the browser window or tab. So that's what we're talking about window. When you're pulling something in as global and you have it open, like you look at mine right now, I have 47 and a half windows open right now. I could have a lot of global scopes running and they can pull from each other. My web page running in my Google Chrome window could pull from the same variable that my JavaScript function is trying to use. So you don't want that to happen. And you'll see more about that when we talk about getting to that point. Okay. So again, it's automatically global if you don't declare it with let, var, or const. And don't create one intentionally unless you intend to, because it can be overwritten. And it can also overwrite other variables and functions. Gives it a lot of power. It's alive when it is declared. function variables are deleted or rendered inactive, if you will, once the function is completed. And in your web browser, global variables are deleted or rendered inactive when you shut the browser window. Function arguments are just one more thing I wanted to throw in there. Function arguments or parameters, because a lot of times when we're declaring variables, we'll put parameters in, like car name, Volvo, car type. We may have several parameters in there. Function arguments, parameters, they work as local variables inside of functions. So I just want to make sure everyone knew that about the parameters and the arguments, that they function as local variables. So I will make sure you have access to this so you can go back and actually, the reason I put this inside of a replit is so that you can go to the script.js and actually copy and paste these and watch them work and see what I'm talking about. But I will give you the link to this scope replit. And I created one for primitive data type so you can play with it later as well. And again, I have the HTML here. It just renders it. Okay. So I'm going to go to the lesson. I'll make sure you have this too. Now we're going to talk about some additional data types, and some of the ones we've briefly mentioned, like strings and booleans, just a little bit more detail. We're going to learn about the null, undefined, and what is a primitive data type. The primitive data types are null, undefined, boolean, number, and string. And we're going to go over what does that mean, that they're primitive data types. And then we're going to go into a little bit more detail with null and undefined, since we haven't used those yet. But when we're talking about JavaScript data types, right here, you have primitive. That's the null, undefined, boolean, number, big integer, string, symbol. Those are primitive. And then you have complex data types, which are objects. And this was just a good diagram for you to refer back to. A variable doesn't associate automatically with a type. In other words, a variable can hold a value of all different types of these. We've done that before when we converted a string to a number and a number to a string, because a variable doesn't automatically associate with one of the types. A car name doesn't automatically associate as a string unless you declare it as a string in the parentheses with the quotations and you format it like a string. So you have to do that. So for example, let counter equals 120. Counter is a number. Counter equals false. Counter is now a Boolean, isn't it? See, what we're saying, that the variable itself doesn't automatically associate with a string or a number. It's what you assign to it that determines that. So we have counter here equal 120. So that data type is a number. Counter is false. That same variable is now a Boolean. Counter equals foo. It's now a string. So this is just to show you that declaring a variable, the variable name doesn't determine the data type. The value that you assign to it determines the data type. To get the current type of value any variable stores, you can use the type of operator. So if we say let counter equals 120 and console.log type of counter, we should get a number. Let's see if we do. So I copied and pasted it. Just that's the reason I did it this way for you, so that you could. I'm gonna go to console. I'm gonna hit run, and it says number. So if you want to know what your program is recognizing as the data type, even though it may be obvious, console.log type of. All that's saying is what type of data is this? And then put the variable name. And it's going to tell you it's a number. That's just a nice little trick to have. And counter equals false. It should be a Boolean. Let's see if that works. seems simple, but sometimes when you're sharing code with other people, you may not know exactly what they intended that to be, but you can see when you do this. See, it's a Boolean. It's saying that counter now is a Boolean because we had false. So just use type of in parentheses. You're going to put the name of the variable, and it's going to tell you what type of data type that is. So again, I will share this with you so you can go back to the script and play with them and make sure it works for you. And like we determined, if we put let counter equals 120, it's going to show number. We did that. Counter equals false, should show Boolean. It did. We didn't run the string, but I'm confident that it's going to show string because I verified these before I put this in here for you so you could play with it. Now we're going to talk about undefined. You'll start seeing a lot of that says undefined. The undefined data type is a primitive type which only has one value, and that's undefined. By default, when a variable is declared but not initialized, it is assigned the value of undefined. So let's look at that. Let's look at an example. We're going to declare a variable called let counter. What's missing? We didn't assign it anything,
Equals.
Find a
did we?
value.
Equals
Right.
something.
So if we put let counter, it's declared, and we declared a variable, but we didn't initialize it with anything. So when you do that, and now we're going to say console.log counter, it's going to say undefined, and type of is going to say undefined because we didn't. We absolutely did not define and assign the value to that. So it's going to tell us that too. Sometimes you do want that to happen, and we'll look at that here in a minute. You want it to be undefined because you'll be putting something in it later. So let's see what happens. Console.log, it's undefined. The type of data is also undefined, exactly as we thought it was going to be. So that worked as it was supposed to. And you can go back and play with these because it's very important. This undefined, as simple as it is, if you declare a variable and don't assign it anything, it's undefined. It's just that simple. It's not an error. It's just undefined. Now, in this example, the counter is the variable. Since counter hasn't been initialized, it is assigned the value of undefined. And then the type is undefined. It's important to note the type of operator will also return undefined when you call it on a variable that hasn't been declared. And we saw that when we put the script in our script.js. Okay, let's see what happens here. Console.log type of undeclared variable. Let's see what happens. You can go back and run these anytime you want to make sure that you understand it, because I know a lot of people, including myself, I have to go through these 2 or 3 times before it starts sinking in and imprinting on my brain, and that's perfectly normal. There's nothing wrong with that. So it says undefined. Again, console.log type of undeclared variable is undefined. So what you're doing here is you're just verifying what we said was true, that if we don't declare don't assign something to that, then it becomes undefined. Now the null type, you see undefined and you see null quite frequently. The null type is the second primitive data type behind undefined and also has only one value, null. Once you assign it something else, null goes away. For example, let object equals null. We're assigning, we're declaring right here a variable equals null. Now let's see what happens. And then we'll talk about why would you want to do that. Object. See, it's going to tell you that it's an object because it's type of. Object is null. The type of object is object. changes it as soon as you console log it. Null runs a little different. And if you work through these examples and the ones in your textbook several times, these should really start making sense. Again, the null type is the second primitive data type, has one value, null. Okay. Now, JavaScript defines null is equal to undefined. Remember, there's difference between assigned and is equal, and is almost equal and is not equal. So JavaScript defines null is equal to undefined in the following way. If you console.log null is equal to undefined, it should come up true. Now let's see if that actually happens. These are just inherent rules inside of JavaScript that are built in. True. So null is equal to undefined is true. So it's almost like null, nada, nothing. Almost similar to undefined, isn't it? So let's look at why we would do one over the other. Now, we've talked about the number type. You use null a lot of times when you're going to, remember when we were writing the testing, and you're going to see that when we talk about the exceptions here in a minute, that's when we're going to use a lot of null. We talked about the number types. I just felt it necessary to put a couple more of the primitive data types in here. It represents both integers and floating point numbers. Can somebody tell me what a floating point number is?
It's a number that
Decimals.
has anything after the decimal. And so
Yes.
like pi is a floating point number.
Yes, absolutely. So the following statement declares a variable. We're declaring let. We're declaring the variable as num, and we're going to initialize it with an integer, 100. Now, to represent a floating point number, you include the decimal point followed by at least one number. Let price, we're declaring a variable named price equals 12.5, which would actually be 12.50, wouldn't it, in US dollars? And we're going to say let discount, we're going to declare a discount of 0.05, which is actually 5%, but this would be a floating point of 0.05. This is how you use numbers and use them correctly if you want to actually include decimal points. Now, what happens if you have a mathematical equation that says 12 divided by 7? What's going to happen? Yes, if you don't declare the type as module, it won't give you the remainder. It'll just say 1, because 1 and something, but if you don't declare the data type to do that, it won't give you that. JavaScript automatically converts your floating point number into the integer if it appears to be a whole number. Now, the reason JavaScript wants to use less memory, and since a floating point value uses twice as much as the integer, it tries not to. Okay. So let's look at this. Let price equals $200. It interprets it and automatically says 200, leaves off the decimals. Didn't need them, did it? It was unnecessary. It was superfluous. Did it change anything by eliminating it? No, except it's using less memory. So it will automatically do that. JavaScript will automatically do that. And to get the range of the number type, you use number.minimum value and number.max value, which kind of makes sense, doesn't it? What's the range of this particular number type? Minimum and maximum. We're going to set the minimum and maximum value. So we're going to say console.log number.max value. And here we've got 1 e plus 308. That's the maximum value. And then we're going to set a minimum value. So you can also use infinity and minus infinity to represent infinite numbers. Finite means you can define it. There is a beginning and an end. Infinite means to infinity and beyond. There isn't a definable beginning and end. So you can use infinity to represent the infinite number. So you can do that as well. And it says infinity. And you see how they did that? Number.max value plus number.max value, it's infinity. So it's just showing you little tricks if you're wanting to use a range of numbers that's specified between here and here, or there is no limit. It's showing you how to do that. We've talked about strings, have to actually use quotation mark, either single or double quotes. Strings are immutable. It means it cannot be modified once it's created. However, you can always create a new string from the existing one. And we did that. We combined them, we separated them, we rotated them, we turned them backwards. You can do that. You can create new ones, but it's not the same thing as modifying it. And I will make sure that I give you these as well. Now we're going to do the last lesson for today. Apologize for the so many. That's just what you all had in your schedule today. And this is going to be exception handling. Let me make sure I have this for you. Joseph, I like your art on there. That's beautiful. I just happened to look down at it. That's beautiful. Okay, now we're talking about exception handling. Handle exceptions. You will see your program will throw, it'll say error and then give you a number. That's going to throw exceptions and errors, and we're going to talk about how do you resolve them, or how do you throw one intentionally. So we're going to talk about JavaScript try and catch. The following example attempts to call the add function. What we're going to do, you can create anything. We're going to try to call a function that actually doesn't exist yet. So we're going to say, declare a variable of let result equals add 10 and 20. Console.log result. Console.log by. Somebody tell me what's wrong with this. It doesn't have, we didn't actually call an add function, didn't we? We didn't create a function at all. So it can't call a function that doesn't exist. So it will issue the following error, uncaught type error right here. Add is not a function. So it's telling you that we didn't create a function before we tried to implement it. And this is what the error is going to look like. So when you see an error come up in your console that says uncaught type error, something is not a function, you can better believe it's because we didn't actually create the function. So you just have to go back, create the function, and then it would run. See, what happens is the message states that add is not a function and it's a type error because we didn't declare any type or a function. When it encounters this error, it issues the error and immediately terminates the execution of your entire script. So when it immediately saw that add was not a function, it immediately terminates the execution of this script, shuts it down, and then gives you the message. Now, sometimes you want to handle the error and continue executing your script. That happens a lot. To do that, you use the try catch statement. Try, and you're going to put a code that might cause error. This could be if you're not sure which way to go. I need to write the code this way or that way. I'm not sure which. One of them's going to error out. So you can say try this code first, catch the error, and then here's the code to handle the error. So you could write one script here and the one alternate here. So if you think this one may error out, you can put the one to handle the error right here, or a message to handle the error right here. And if this script does not cause an error, this simply will not run. It's like the if. Try this. If it doesn't run, gives you an error, it's going to run this code. If it works, it just won't run the catch error. Now let's look at it. First, place the code which may cause the error in the block. Implement the logic to handle the error. It's as simple as that. If an error occurs in this try block, The JavaScript engine will immediately execute the code and keep moving. And the engine will provide you with an error object which contains detailed information about the error. Now, basically, the error object has two properties. Name specifies the error name, and message will explain the error in detail. And that's what you saw up here. It's going to give you a message and a name, type error, and it's going to describe it. Okay. Now, if no error occurs in that try block, like we said, it ignores the catch block. Now, here's a note that web browsers may add more properties to the error object. For example, Firefox adds file name, line number, and stack to the error object, just for you to know, depending on which browser you end up working with. Right now, we mainly work with Chrome, and you're not going to see file name, line number, and stack. But if you're using Firefox, you're going to see these come up in your error message. Now, it's good practice to place only the code which you think may cause an exception in the try block. Don't just put anything there. Put something that you think may actually cause an exception. And this chart is going to show you how the try catch statement works. You're going to stop that. Makes it smaller. You're going to hit start. It's going to try. It's going to run that block of code. If there's an error, yes, it's going to run the code that you specified in the catch. If the error is no, we're just going to end it and it's going to keep going because we don't need the catch. So it's like a plan B. It's only executed if necessary. Now let's look at a couple examples. Try let result equals add 10 and 20. Console log result. We know that's not going to work. We know that. So we're going to create a catch statement, which is an error. This is what this E inside of the parentheses means, error. Console.log name, error name, message, error message. So it's going to tell us exactly what went wrong. That's what we want it to do. So that's going to tell us if we're not sure that this line of code will work, we want it to tell us what the name of the error was, the error and the message and the error message, because that will help us correct the code. These are the things that we're going to need to know. If we're not sure this is going to work, we want to catch this information so we can actually correct the error if we're not sure. And then it's going to say bye. It's just going to end. So what's going to happen here, if we run this particular line of code, it's going to say name, type error. We know that we saw it above. Message, add is not a function. And then it's going to say bye. It's just going to end the program. So we called the add function. We assigned the return value. Add didn't exist. It skips the statement because it didn't exist. Then it's going to refer to the catch block, which is catch the error, give me the information. And then it's going to output by, let us know that we're ending the program. Now ignore the catch block. The following example defines the add function, which returns the sum of two arguments. So we're going to say const add. See what we did there? X and Y. Then the arrow function, X plus Y. So we're actually going to add X plus Y. Try, let result equals add 10 and 20. Result. Catch, error, by. Now what's going to happen? The output is actually going to be 30 because we did declare the variable here, and we declared what we wanted to do with it using the arrow function in JavaScript ES6. So by doing that, it's actually going to execute the try block, add 10 and 20. We don't have to do the catch because there's no error, and then it's going to output by. No error occurred. Now the exception identifier, when an execution occurs, and when an exception occurs in the try block, the very first one, the exception variable E in the catch block will store that exception object for you. If you don't want to use this exception variable, you can omit it. Try, put your code, catch, put what you want to happen. For example, let's look at this. Const is valid JSON. You don't have to worry about that now. It's just, is it going to be a valid JSON? Equals string arrow function, we're going to try JSON.parse. Can we parse the string? Return true. If that errors out, it's going to return false. So let's see what happens here. First, define the isValidJSON function that accepts a string and returns true if the string is valid JSON or false otherwise. To validate it, it uses the JSON.parse. You will use this a lot. We just haven't got to the HTML and JSON yet. The parse method parses a JSON string and returns the object. If it's not valid, it throws the exception. That's what we're trying to get you to see right now, not what JSON is. If it's actually a string, it will return true. How many of you have ever uploaded a document into a website and it says, can we parse the data and fill in the resume? That type of thing, where it's going to pull the data and try to put it in the blocks for you. That's what this is going to do. JSON is going to parse and see if it's a string, and it's going to return true or return false if it isn't. So that's what we're going to do. If no exception occurs, it returns true in the try block. Otherwise, it returns false. Then we're going to call the isValid function and pass the string into it. That's what we're doing right here. If it's a valid JSON language, JavaScript, valid. So it's telling us what to do. So we're going to say let valid equals isValidJSON, and then it's going to console log valid. It's just going to tell you, yes, it did work. It was true. There was no exception. There was no error. So the summary of this one is we try to use the try catch statement to handle exceptions in JavaScript. Place only the code which may cause the exception in the try block, and then what you want to happen in the catch block. Now, JavaScript throw exception, you'll see this a lot. We're going to learn how to use the throw statement to actually throw an exception. The throw statement will allow you to throw an exception with this syntax: throw expression. Throw, then you're going to write an expression. In this syntax, the expression specifies the value for the exception. Just like declaring a variable and then the value of it, the name, that's what expression is. Typically, you'll use a new instance of the error class or its subclasses, but we're just going to show this. When encountering a throw statement, the JavaScript engine stops executing whatever it's doing and passes the control to the first catch block in the call stack. You're going to see as we go on that you'll have a lot of try and catch as we get further along. Now, when it sees a throw statement, it's going to immediately stop executing the script it was in, and it's going to immediately hand over the controls to the very first catch block that you have. If no catch block exists, it just terminates the script. Now let's look at some throw examples. Let's take this. Let's say we're going to use a JavaScript throw statement function. Again, we're going back to our add X and Y. If type of X, what's this operator mean?
Does not equal.
Not equal.
If type of X is not equal to a number, throw, the first argument must be a number. You see how we're doing throw? It's going to throw a statement. The first argument must be a number. If type of Y is not equal to a number, we're going to throw the second argument must be a number. So we're throwing a statement, an expression. And then we're going to return X plus Y. Now, we're going to construct the result with a constant, add A and 10. What's going to happen if we add A and 10 based on all of this?
I think it's outside the function, right?
And it's going to say the first argument must be a number, isn't it? It is
Yeah.
outside the function, and it's not a number, right? It says it's type of is not a number. It's going to throw a statement that says the first argument must be a number. Is this a number?
No.
So it's 1, yeah, it's outside of the function, and 2, it's going to throw a statement that says the first argument must be a number. Now, how it works, you're going to define the add function, which we've done. It's going to accept 2 arguments. The arguments that we had are X and Y. right? And return the sum of them. The add function uses a type of operator right here to check the type of each argument and throw an exception if the type is not a number. It's going to check each of the add functions, each of these arguments right here, and make sure that they're both numbers. Okay, it uses the type of to make sure. Now, second, we're going to call the add function, right? And pass a string and a number into it, which is what we're doing right here. Add A and 10. Now, third, show the result to the console. The script causes an error because the first argument A is not a number. And this is what it's going to say, uncaught. The first argument must be a number. So it's going to give you the statement that you ask for it to give you. It's just another way of controlling what's going on in your programs. If it is not a number, you're going to throw an error, throw a statement, throw an alert. That's the first argument must be a number, and the second number must be a number. Now, to handle the exception, you can use the try catch statement. Let's look at that. We're going to go back to, we're going to add X and Y. If type of X is not a number, we're going to throw the first argument must be. If the type of Y is not a number, the second argument must be a number. Return X plus Y. So far, so good, right? Now, let's try. Now we're doing the try and catch, aren't we? Try const result equals add A and 10, which we've done, and get a result, which it should be isn't a number. And we're going to have catch the error. And we want to print to the console log the error message. So the output is going to be the first argument must be a number. It did exactly as we asked it to. It tried to run the program. When it got down to here, it's like, wait a minute, this A is not a number. We're going to console log the result, or we can't because in the try, it isn't a number. So we're going to revert to the plan B, the catch for the error, and we're going to print to the console log what the error was, the first argument. You'll see this over and over again. Okay. Now let's see. We have a couple more things for you. Sometimes you're going to also want to throw a custom error rather than the built-in error, because there's all types of built-in ones like the 404, the 402 that you see pop up when a website says no longer exists. So you can define the custom error class that will extend your error and throw a new instance. So let's define the number error. Class number error extends error. We're just taking a class, which was error, and we're going to add to it, like parent and child. We're adding number error to the error itself. We're going to constructor of a value. Super, we're going to talk about that here in just a second. With the backtick, what does this mean when we put the $, curly brackets? What did we say that was?
Temporal, right, literal.
Yes,
literal.
Yes, y'all are fantastic. So we're doing the same thing we did up here, but we're doing it in another way. We're going to say, we're going to create a super template literal that says is not a valid number. This dot name is going to say invalid number. So what we've done here is the constructor of the number error, which is right here, accepts a value you'll pass into it when you create a new instance of this class. This value here hasn't been determined yet. In your program, though, you will pass values into this as you go. Okay. And now in the constructor right here of the number class, we will call this constructor via the super. We'll go over that too. And pass a string to it, which is right here. And we override the name of the error, because this is what we're trying to do, to the literal string number error, because we created it right here. Instead of it going through its normal process that we went up the top, we're overwriting it and we want it to tell us right here, we will construct the error via super, pass our own string. We're overriding the default name and we're going to pass to it the number error. And if we don't do this, the name of the number error will just be error. But we want it to say number error. And that makes sense, doesn't it? Because it's a number error. It's an error with the type of data. Now you'll see this a lot. You'll be doing a lot of this later. Now in the constructor, let's look here. Second, use the number error class in this add function. We're going to add again the X and Y. Now if type of X is not a number, we're going to throw new number error, right? If type of Y is not a number, we're going to throw new number error, return X and Y. Now let's look at what happened, what we just do. In the add function, we throw an instance of the number error right here if the argument is not a valid number. And then we're going to catch the exception thrown by the add function. Okay, so we're going to try, add A and 10. We know that doesn't work. So we're not going to get a result. We're going to go to plan B, the catch error, console.log error name, error message. So this is what we're going to output. Number error. A is not a valid number. So what we did was we changed it to say what we wanted it to. Instead of just saying type of error, we wanted to say number error, because when you have 1,000 lines of code, you want it to be as specific as you can for your benefit and for those of the programmers working with you. It is an error because it's not a valid number. Can you call it anything you want to? Absolutely you can. You can call it anything you want to. This just tells me it was an error with the numbers because this was not a number. Or I can say, Vicki, you're stupid. You know that this has to be an integer. That'd be a long one though. So the exception name is number error, isn't it? And the message is the one we passed into the super. Number Clara asks, which is right here. So we use the JavaScript throw statement to throw user-defined exceptions so that it tells us what we want it to or does something else. Okay. So I'm going to make sure, I'm going to put these out there in the general for Slack because it's 7. And if you have any questions, by all means, reach out to me in Slack. I apologize we didn't get to actually go through a lot of the code because there was 3 different lessons today. And I'm sure you'll get a lot of help from your TAs, your assistants in your studios, but I'll be sitting right here doing some things. If y'all need me, reach out for me. This was a lot of information. Please work through some of these if you get a chance. And can't wait to see you on Thursday.
Thank you.
Thank you.
Thank you.
Thank you, Dr. Vicky.
You.
Thank you.
Thank you, Doctor.
Thank you. You all were fantastic.
Thank you.
Thank you.
Best class ever. Biggest class ever and my best class ever. That's saying something. You guys are awesome.